Hello everyone, just an update on things. I've come to notice that lately in my last video demonstrations, especially with the various RF and antenna building, that people are getting mostly lost. Not all of you, but a very good majority, unfortunately. And I have basically a hard time teaching every concept from scratch, right? Especially when I know it's very traditional stuff. And I get it. Some people are getting upset at me because they want that step by step that basically I'm just part of it is a lot of this would require a lot of fancy video editing, and you can see it on YouTube for traditional electronics. And I'm not even talking about ham radio here, just radio engineering in general. Ham radio, I think, is a lousy term and even deceptive because people figure, they associate, a guy talking on a walkie-talkie and the mic, that's ham radio. I'm not interested in the communications part of it at all. But in the industrial sector, radio engineering is a big thing, and it's part of ham radio naturally. So I tend to short form it and call it ham radio, but really it's radio engineering, and that has been around for ages. And with that said, there are beautiful videos, and these people are graphic designers, graphic artists. They went to school for this stuff. They make beautiful animations. I lack that ability to do that for you guys so you can understand these basic circuits. That's what I'm getting at. We all have our strong points, and this is not one of mine. So it would be very sloppy and maybe just more deceptive by the time I'm done trying to explain it to you than just having one on your own to find someone who has done it very professionally. So as I've said before, I've recommended a few good books and resources, and you can take it from there really. And I guess with that said, I must be progressing a little fast here, and it's confusing, especially people who are just coming around here. There's always new subscribers, so they don't get the exposure of the earlier stuff. So what I'm going to do here, what I decided to do, is take a step back a few notches and go back to some of the basics here. And I've worked on a circuit, something that I'm also actively working on in the background here, which is a very simple circuit that I really feel that just about everyone here that follows me, many of you have already replicated the peg cell and knows how it works. So you can use these parts easily to reproduce these effects, and it's a very fun, very simple circuit, easy to reproduce, and shows you the basic effects. And essentially one of those circuits to have fun with, learn with, easy to understand. And it makes one go, it's one of those things to make you think, okay? Because essentially it's a way of getting a very long-lasting pure potential of 100 volts and over, real RF oscillations kind of deal, real magnetic fields. So basically what you want to do with that next is up to you. You see, that's the starting point. So now basically a lot of our circuits depend on having a very high potential for very little. Well, here's your way of creating that very high, basically electrostatic, but instead of being a volt or two, it's 100 volts, maybe even more, you see. So what can we do with that? I mean, your ideas are as good as mine. I mean, get to the drawing board. One of the main things we like to exploit is potential differences. So you've got your high potential there, which is basically 100 volts for very, very little input, either a peg cell or a half-dead battery, whatever you want to use. It will simulate the very similar effects. So naturally, what happens is the peg cell is nice because it has self-electrostatic regauging abilities, while a normal battery, even though you'll be able to use it, there's a chemical issue here. Once you deplete the batteries, they'll actually rot and everything else. So you can only play this game so much with a regular battery, but you will be amazed just putting a regular 9-volt battery in there that's quote-unquote dead will sustain your 100 volts oscillation for a week or more. So that's what I mean. You end up using that little energy for very long. So if you have a week of a trigger, you see what I'm getting at? That gives you 100 volts potential difference. What can you do with that now? So a lot of people like the idea of maybe splitting the positive. Is this splitting the positive? Let's say if we were to put 2 ground rods somewhere in the ground, that makes basically a very high resistance loop. So the thing is, even if you touch on each side, you're not going to notice it because you're on. That's the reason why we don't get zapped, even if the ground may have billions of volts, but it's still a different potential. So what I'm getting at is maybe I'm wrong, but maybe something to try. Isolate the device, make sure it's well elevated and not grounded, and have your two ground loops, put that in a coil, run a switch. What I'm getting at is whatever potential in millions of volts it could be from the ground, isn't this a perfectly free source of modulating your high potential, which is, I call it high potential because we're producing a potential, so it's 100 volts, but we might be modulating that 100 volts with thousands of volts if we send it, you know what I'm getting at? Switch it across a coil. To us, it's going to be zero, but in reference to the machine, that's going to be a major potential difference. So essentially, the device may see a very high potential being modulated, if that makes any sense. So is that a form of splitting the positive? You tell me. So it opens the door again for exploring and understanding what it is we're looking at in a much simpler form. So I'm going to show you the circuit right now, and feel free to experiment with this. I even have a little Outlook, a voiceover that explains the circuit in detail. So here it is for you right here.
This circuit is designed to exploit the energy characteristics of low current sources, such as PEG cells or depleted batteries, by leveraging electrostatic regauging effects and high-frequency harmonic generation for efficient energy transfer and utilization. Power source, PEG cell, or low current battery. The circuit operates using a PEG cell, which demonstrates electrostatic regauging properties, ensuring a prolonged operational life. The PEG cell provides a minimal current, approximately 1 milliamps, while maintaining sufficient potential to drive the system. A small, efficient oscillator circuit acts as the primary load, converting the input energy into oscillations. The oscillator is designed to function with high impedance, allowing it to operate effectively at low input currents. The neon lamp as a spark gap and limiter. The neon lamp is connected to the high voltage HV side of the circuit. It serves multiple roles. The neon lamp limits the high voltage spikes to prevent overloading of downstream components. The intermittent discharges produce nonlinear behavior, creating a wide spectrum of high-frequency harmonics. The noise and harmonic spectrum generated are crucial for driving subsequent circuit stages efficiently. AV diode plug. This component directly connects the high-frequency output from the neon lamp. It extracts and rectifies the harmonic-rich energy into a unidirectional flow compatible with one-wire energy transfer systems. A supercapacitor is introduced to the output of the AV diode plug. Its role is twofold. Energy storage. The supercapacitor captures energy efficiently from the diode plug, leveraging its low impedance to minimize thermal losses. It provides a stable discharge current to the oscillator, effectively balancing the PEG cell's input with the additional energy gain from the circuit's operation. While initial attempts to feed energy back into the PEG cell did not enhance its voltage or output, placing the supercapacitor in series with the PEG cell and oscillator created a synergistic effect. This configuration resulted in a noticeable increase in oscillator speed, brighter flickering of the neon lamp, indicating improved energy flow. Summary of operational principles. The circuit operates with minimal energy draw from the PEG cell by exploiting its electrostatic properties and high impedance design. It's harmonic utilization. The neon lamp's discharges generate a broad spectrum of harmonics, which the AV diode plug efficiently converts for further use. The supercapacitor acts as an impedance bridge, enabling effective energy transfer and reducing losses. Self-amplifying feedback. The system stabilizes and amplifies its operation without additional external energy input, leveraging the energy flow between the PEG cell, oscillator, and supercapacitor.